Hi again, Fernando here one more time with another stoichiometry problem. In this problem, I want to explain a very important case to you. I'm talking about the calculation of the limiting reactant.
Binnacle project.
Let's read together the statement. It says that 600 grams of sodium nitrate are reacted with 400 grams of potassium chloride, producing sodium chloride and potassium nitrate. Section A says, determine the limiting reactant and the amount of excess reactant remaining. Section B says, calculate the mass of the products obtained. And Section C, as always, says, verify Lavoisier's law. So the first thing we're going to do is to write the chemical equation. Let's do it. Sodium nitrate. This is sodium nitrate. That is reacting with potassium chloride. This is potassium chloride, in order to obtain sodium chloride and potassium nitrate. Okay? And of course, the first thing we're going to do is to balance it. One sodium atom on the left and also one sodium atom on the right. One nitrogen atom on the left and also one on the right. 3 oxygen atoms on the left and also 3 on the right. One potassium atom on the left and also one on the right. One chlorine atom on the left and also one on the right. So the equation is already balanced. And now let's place properly the amounts of substances that they are giving us. 600 grams of the first one and 400 grams of the second one. And how do we know that we have to calculate the limiting reactant? Not only because Section A is asking us to do it, but always whenever you are given amounts of 2 reagents. Whenever you are given amounts of 2 reagents at the same time, as in this case, we have to calculate the limiting reactant, because you have to consider that one of these substances will be the first in disappear, and at that moment the reaction will stop. Okay? It is called the limiting reactant because it will be the first substance in disappear, and then the reaction will stop. Using the limiting reactant, we will calculate the amounts of products. So, which one is the limiting reactant? I'm sure that you are thinking that perhaps this one is the smallest one. But I'm afraid that in chemistry, reaction occurs not gram by gram, but mole by mole. So I'm afraid that we can't choose this one directly as the limiting reactant. We have to make calculations. So how are we going to do it? Look, please choose one of these substances. The first one or the second one, it doesn't matter. Let's choose, for example, the first one. And we are doing our calculations in order to know the amount of the second substance that will react with this 600 grams of sodium nitrate. We are calculating the grams of potassium chloride that will react with our 600 of sodium nitrate. And then we will compare our result with this one. Okay? That's how we are going to do it. So, look. First of all, let's place here 600 grams of sodium nitrate. And as always, we are using this first conversion factor in order to kill grams of sodium nitrate in order to get into moles of sodium nitrate. As always, with 1 mole will be enough to do this calculation. And now we have to add sodium atom. Look at its mass, 23, plus nitrogen, 14, plus 3 oxygen atoms, so 3 times 16. Let's use the calculator. 23 plus 14 plus 3 times 16. It gives us 85. If you have in your hand 85 grams of sodium nitrate, you will have 1 mole of that substance. Now there comes the second conversion factor. It will help us to change from moles of sodium nitrate to move into moles of potassium chloride. And there comes the stoichiometric coefficients, 1 to 1. And of course, there comes the third conversion factor, which will help us to move from moles of potassium chloride to get into grams of this substance, potassium chloride. And with 1 mole, we will have done this calculation, okay? Now it's time to add the atomic masses. Potassium 39 plus chlorine 35.5. Let's use our calculator to do 39 plus 35.5. It gives us 74.5 grams of potassium chloride is 1 mole of that substance. And now we are using our calculator to know how many grams of potassium chloride are going to react with these 600 grams of sodium nitrate. Look, let's do 600 multiplying 74.5 and divided by 85. It gives us 525.88 grams of potassium chloride. Our 600 grams of sodium nitrate wants to react with 525.84 grams of potassium chloride. So, is there enough substance in this problem? No, there are only 400 grams. So this is the limiting reactant. Please don't forget what we've done. We wanted to know how many grams of potassium chloride will be necessary to react with this 600 grams of sodium nitrate. And our calculations say that will be necessary 525.88 grams of potassium chloride. Is there enough? No, there are only 400 grams of this substance, so this will be the limiting reactant. And now that we have finally found the limiting reactant, which is this one, we are calculating the amount of this substance that will react with our 400 grams, okay? So let's do 400 grams of potassium chloride. As always, the first stoichiometric factor, conversion factor, will help us to move from grams of potassium chloride to move into moles of potassium chloride. Only with 1 mole will be enough to do this calculation. And now let's add potassium 39 plus chlorine 35.5, which gives, as previously, 74.5. Now we are moving from moles of potassium chloride to get into moles of sodium nitrate. And there comes the stoichiometric coefficients, which are 1 and 1. And finally, the third conversion factor, as always, helps us to move from moles of sodium nitrate to get into grams of sodium nitrate. With 1 mole, we will have done this calculation, and if you add the atomic masses, it gave us 85. Now, let's use our calculator, because don't forget that as we have discovered that this is the limiting reactant, this 400 grams of potassium chloride will disappear. We are calculating with how many grams of the other substance are going to react. So let's use our calculator to do 400 multiplying 85 and divided by 74.5. So look, our 400 grams of limiting reactant will disappear, will react with 456.37 grams of sodium nitrate, okay? And finally, in order to calculate the amount of excess reactant remaining, we are just doing 600 grams minus 456.37. And at the end of this reaction, we will have 143.63 grams of sodium nitrate remaining. And that's all.
Binnacle project.
As I ran out of space, I erased the whiteboard, but I've written here the results of our previous calculations. 456.37 grams of this substance will react, will move to be products with these 400 grams of potassium chloride. And 143.63 grams of this substance will remain. And now it's time to calculate section B, calculate the mass of the products obtained. And now we are doing this calculation using the limiting reactant. So that's why it's very important to obtain which one is the limiting reactant. We are using two trains of conversion factors, 400 grams of potassium chloride in order to calculate the grams of sodium chloride, and another train, 400 grams of potassium chloride in order to calculate the grams of potassium nitrate. And let's do it. The first conversion factor moves from grams of potassium chloride to move into moles of potassium chloride. With 1 mole, we are doing this calculation, and let's add 39 plus 35.5, which was 74.5. Second conversion factor will move us from moles of potassium chloride to get into moles of sodium chloride. And there comes the stoichiometric coefficients, 1 to 1, 1 to 1. And finally, we are moving from moles of sodium chloride, with 1 mole will be enough, to move into grams of sodium chloride. And now it's time to add the atomic masses of these atoms. Sodium, 23, as you can read from the statement. And chlorine, 35.5. 35.5. Let's use our calculator, and we have 23 plus 35.5. It gives us 58.5. And now, in this reaction, we will obtain 400 multiplying 58.5 divided by 74.5. It gives us 314.1 grams of sodium chloride. Easy, right? And now it's time to move from 400 grams of potassium chloride to calculate the amount of potassium nitrate that we are obtaining. And we are doing almost the same. The first conversion factor, as always, helps us to move from grams of potassium chloride to move into moles of potassium chloride. 1 mole of potassium chloride is 74.5 grams of potassium chloride. The second conversion factor helps us to move from moles of potassium chloride to get into moles of potassium nitrate, okay? Moles of potassium nitrate. And there comes the stoichiometric coefficients, 1 to 1, 1 to 1. And the last conversion factor will help us to move from moles of potassium nitrate, with 1 mole will be enough to do this calculation, and to express the solution in the form of grams of potassium nitrate. And now we have to add the atomic masses of these elements. Potassium 39 plus sodium 14 plus 3 oxygen atoms, so 3 times 16. 3 multiplying 16. Let's write in the calculator. 39 plus 14 plus 3 times 16. It gives us 101 grams of potassium nitrate is a mole of potassium nitrate. And finally, let's do 400 multiplying 101 divided by 74.5. So in this reaction, we are obtaining 542.28 grams of potassium nitrate. And that's all.
Binnacle Project.
And now it's time to verify that everything went well by doing the third section, which says verify that Lavoisier's law is satisfied. So what are we going to do? We are adding the amounts of reagents. In this case, not this 600 grams of the first substance, because these 600 grams are not the total amount of substance that reacted, but 456.37 grams of this substance. So we are doing 456.37 plus 400 of potassium chloride, which is for 856.37 grams at the reagents. And now we are adding in the products, of course, 314.1 plus 542.28. And now please use your calculator and you will see that it gives us almost the same. 856.38 grams in products. So this is the Lavoisier's law. This is not a coincidence. This is science.
Binnacle Project.
And don't forget what we've done. In this problem, we were given the amounts of 2 substances, 2 reagents at the same time. And we have to consider that one of them will be the first one to disappear. That will be the limiting reactant. Don't forget how we did it in the first section. And we concluded that this one, the limiting reactant. Using this substance, we calculate the amount of the other one that could react. Using this limiting reactant, we also calculated the amount of products. And finally, you can see that Lavoisier's law is completely satisfied. So, that's all. See you soon. And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!